Try to imagine for a moment a place so extreme, so unapologetically perplexing, that our very understanding of physics begins to break down at the fundamental level. A place that even the fastest known objects in the universe cannot escape. These are black holes, cosmic enigmas that defy our understanding, challenge the limits of science, and yet play a central role in shaping the universe. In this video, we'll dive deeper into what exactly black holes are, how they challenge our understanding of the universe, and why they are so important in shaping the cosmos. So what exactly is a black hole? A black hole is an area in space where matter is condensed to unimaginable levels. To put it into perspective, imagine condensing the matter of an entire star down to the size of Manhattan. The gravity around it becomes so intense that not even light, the fastest thing in the universe, can escape. Despite how unsettling that may sound, black holes are not as scary as they are sometimes portrayed. In fact, if the Sun were replaced with a black hole of the same mass, the Earth wouldn't change in orbit at all. What makes black holes unique isn't just their mass, but the fact that this mass is concentrated in such a small space, creating extreme gravitational effects, like the event horizon, that you won't see anywhere else in the universe. It's only fitting that one of the most extreme objects in the universe would have an incredible origin story. And black holes certainly do not disappoint. Black holes form when an extremely massive star, one at least 8 to 10 times heavier than the Sun, runs out of fuel. When this happens, the star no longer produces nuclear fusion, and the effects of gravity take over. The result of this process leaves behind a black hole and is the most widely known belief of how they come to be. Scientists have also discovered objects known as supermassive black holes, or black holes with the mass of 1,000 suns. It is unclear how these black holes formed, but there are two popular theories. The first is that after the formation of multiple black holes in a small area, they merge together to form one gigantic black hole. The other theory is that a supermassive black hole could form from a direct gas collapse, where there is so much gas in one area that it becomes a black hole on its own. Both theories have their weaknesses, and ultimately the existence of supermassive black holes is widely regarded as a mystery. We've covered how black holes are the result of collapsing stars, but what exactly are they made of? Black holes are often depicted as massive empty voids in space that seem to be made of nothing. This nothingness that we see is what's known as the event horizon. This is the invisible boundary of a black hole that, once crossed, cannot be escaped. This area essentially defines the black hole itself. The matter of a black hole is believed to be condensed into a single point known as a singularity. This is where our understanding of everything we know about physics begins to stop making sense. No light, information, or matter can escape the gravitational pull of this point, making it impossible to tell what exactly happens there. Some theories suggest that singularities might hide secrets about quantum gravity or even the birth of new universes. But it is undeniable that whatever secrets they hold would change science as we know it. Black holes are known to be invisible objects that are undetectable via telescopes. If this is the case, then how do astronomers detect these objects? The answer for the discovery of most black holes is the accretion disk. The accretion disk is a spinning, glowing disk of gas, dust, and stellar debris being pulled toward the black hole. As this material spirals inward, it rubs against itself, creating friction and enormous heat. The disk can reach millions of degrees, causing it to emit powerful X-rays and light that astronomers can detect from millions of light-years away. Black holes aren't just cosmic oddities, they're natural laboratories for the most extreme physics we know. Near a black hole, Einstein's theory of general relativity takes center stage. Space-time itself bends so sharply that time slows down for anyone close to the black hole compared to an outside observer. This effect, called time dilation, means that if you were hovering near the edge of a black hole, you'd see the rest of the universe race forward while for you, only moments had passed. Then there are tidal forces, differences in gravity between your head and feet, so extreme they could stretch you into something scientists call spaghettification. Black holes show us how fragile our everyday concepts of time, space, and matter really are when pushed to the limit. But how do we know these exotic effects are real if no one can see a black hole directly? The answer lies in what black holes do to their surroundings and the evidence they leave behind. For something invisible, black holes leave a surprisingly loud signature in the universe. One way we detect them is by watching stars. Some stars orbit seemingly empty space until you realize the nothing they're circling has the mass of millions of suns. That's how astronomers identified the supermassive black hole at the center of our own Milky Way, Sagittarius A. In 2019, humanity captured the first direct image of a black hole's shadow in galaxy M87, thanks to the Event Horizon Telescope. This blurry orange ring wasn't just a picture, it was confirmation that Einstein's predictions, made over a century ago, still hold true. And when two black holes collide, they don't just disappear quietly. They unleash ripples in space-time itself, called gravitational waves. Instruments like LIGO and Virgo have detected these faint tremors, allowing us to quite literally listen to the universe as black holes merge billions of light years away. All of this raises a bigger question. Why do black holes matter? Why should we care about something that seems so distant, so destructive, and so removed from our daily lives? It's easy to think of black holes as distant curiosities, but they are central to the story of the universe. Supermassive black holes act as anchors for galaxies, shaping their structure and influencing the birth of new stars. Without them, galaxies as we know them might not exist at all. But black holes don't just matter on the cosmic stage, they matter for physics itself. Every time astronomers measure the light swirling in an accretion disk or detect the faint signal of a merger, they're testing Einstein's general relativity under conditions no human-made experiment could ever replicate. So far, relativity has passed every test, but physicists know there must be more to the story. That's because black holes also force us to confront a paradox. When quantum mechanics collides with general relativity, the math breaks down. What happens to information that falls into a black hole? Does it vanish forever, or is it somehow preserved? This information paradox has baffled scientists for decades, and solving it could lead to a unified theory of physics, one that explains everything from the tiniest subatomic particles to the largest galaxies. So black holes aren't just cosmic monsters, they're puzzles, teachers, and maybe even gateways. And that brings us to the bigger picture. What black holes mean for our future understanding of the universe. Black holes are paradoxes made real, objects that erase everything we know about matter, time, and space, yet reveal so much about the cosmos. They are destroyers and creators, monsters and mysteries, simultaneously terrifying and inspiring. They remind us that the universe is stranger than our imaginations, and that the frontier of science lies not in what we already understand, but in what still confounds us. Every new discovery about black holes is a step closer to answering humanity's oldest questions. Where did we come from? What rules does the universe truly obey? And is there an ultimate theory that ties it all together? As we continue to study them, one thing is clear. Black holes will remain at the very edge of human knowledge, daring us to push further. So the question remains, are black holes the ultimate dead ends of physics or the beginning of something even greater? Thank you for watching. If you enjoyed hearing about the oddities of black holes, be sure to subscribe for more content like this. And leave in the comments below ideas for what you would want to hear about next. Take care and never stop exploring.